Hello everyone, this is Mrs. Snook with section 4.5, and we're going to graph sines and cosine functions. So our objective is to graph the basic sine and cosine functions, and then we're going to start using amplitude and period to help sketch those functions so we can actually change amplitude and period and they will change the graph. And we're also going to do some translations, things like shifting left and right. And if we do a left-right shift, we call that a phase shift. And sine and cosine functions, believe it or not, are super practical in the real world. This is how engineers model radio waves. And if I change the amplitude of a radio wave, that's just like if I'm listening to music and I turn up the volume. So you can think of this as the volume, like of your speaker. If I start changing the period, now I'm changing my radio station. I could be like turning the dial and going from one radio station to a different one because they have different periods, different frequencies they transmit on. So with that in mind, let's start learning about our basic sine function. We're going to do sine function first in this example, and then in our next example, we'll look at the cosine. So first of all, to do a graph by hand, what I need is an XY table. And in this case, y is going to be the sine of x. And when we graph the sine function, we actually graph in what we call critical points. And those points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. The sine of 0 is 0. So that's right here, and that's where it intersects the x-axis. And your book calls that an intersection. Sine of pi over 2 is 1. Sine of pi is 0, so you got another intersection. Sine of 3 pi over 2 is -1. And then sine of 2 pi is 0. Now notice we've completed what's called one cycle. We've gone up, down, and back up. That is the period. And notice it got as high as 1, so that's a max. And then as low as -1, so that's your min. And then at pi, you have an intersection. And at 2 pi, you have an intersection. So those are your critical points. You're going to have 5 of them. The left, the intersection, the left, the maximum, intersection, minimum, intersection, or right point. And this is a periodic function. That means it repeats. So it's going to do the same thing over on the left side. So our whole sine function is going to look like that. Now, when we do 2 times the sine function, that's just like applying a vertical stretch. So I'm going to multiply each of these points by 2. I'm going to keep their x locations the same, but I'm going to double the y value. So here, it was 1, now it's 2, 0. Was 1, now it's 2, 0. Does the same thing over here. Okay. The other thing I want to point out is from here to here, that distance there, that's called the amplitude. And that is governed by this coefficient right here. So in our parent function, y equals d plus a sine of bx minus c. That's our parent function. A right here governs the amplitude. Okay. All I did is I changed the amplitude. All right, our next example, we're going to do some more changing on that vertical axis. Again, we're going to use a parent function. This time it's cosine, so our parent function is y equals d plus a cosine of bx minus c. And the only thing we're going to play with is this a. That's the only thing that's going to change the amplitude. But now we're using cosine. We're still going to have the same critical points, but their values are a little different. So I'm going to get us an xy table. We're going to use 0, pi over 2, pi, 3 pi over 2, and 2 pi. And y is going to be the cosine of x. So here's our xy table. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is 1. So now look at this one. This is a max. Here's your intersection. Here's a min. Here's the intersection. Here's a max. We've got the same critical points, but the maxes and the intersections are all different than the other ones. So now I'm going to apply our change in amplitude. A equals 1/2. So the amplitude is 1/2. Strictly speaking, the amplitude is the absolute value of A. So absolute value of 1/2 equals 1/2. Because I always want my amplitude to be positive. So when I'm graphing this one, my amplitude instead of 1 is 1/2. So that just changes our max and min. Our intersections are still in the same place. So like that. You can see a vertical compression. Then the other one, 3 cosine x, that just changes the amplitude, but instead of being 1, it's now going to be 3. A equals 3, so from there my amplitude is 3. So here's 3, that stays at 0, negative 3, 0, positive 3. There you go. Now we've got our cosine graph of the 3 cosine x. All right, so we've done some scaling vertically. Now we're going to do a horizontal one. And notice that's happening right here. It's inside the sine function. Again, y equals d plus a sine of bx minus c. What we have in here is a b. This is b, and b equals 1/2. Also, a equals 1, and I don't have a d or a c. D equals 0, c equals 0. So I don't have any phase shifts. I'm just going to scale horizontally. And so then I need to figure out what my period is. Since I'm scaling horizontally, my period changed. The equation we're going to use is period equals 2 pi over b. B here is 1/2. So period equals 2 pi over 1/2, and that equals 4 pi. All right, Just like before when we had critical points, we have to do our same critical points. All right, now this time we are going to divide our period by 4. So now each critical point, I'm going to take this period, I'm going to divide it by 4. I don't have any shifting, so I start at 0. But instead of going pi over 2 for the next one, divide 4 pi over 4, and I get pi. So I'm adding pi each time. Add another pi. Add another pi. Add another pi. So my critical points, all I did is divide my period into 4, and that's defined my points. And so now our amplitude, we said is 1, because A is 1, so amplitude is 1. So that means my maximum is going to be here at 1. My minimum is going to be at -1. So I'm just going to kind of, sketch this in as a visual to remind me to stay between those lines. Sine function, my first critical point is an x-axis crossing, so it's 0, 0. That's my first one, right there. My next critical point is a maximum. My amplitude is 1, so I just put in 1. So at pi, I'm at 1. My next critical point for a sine function is a crossing. So I put 0. So that's right there. Next one is going to be a minimum. So that's -1. And then my last one is an intersection with the axis. So here's this one. There's our sine function. This is with a horizontal stretch. And I could keep going this way because it is periodic. Okay. Now the next one, this is getting a little bit more complicated because check it out. I have a change in my amplitude. I have 1/2, and I'm going to have a phase shift. So go back to the parent function. Y equals D plus A times the sine of bx minus c. So here, D equals 0. A equals 1/2. So therefore my amplitude equals 1/2. We have B equals 1. So my period equals 2 pi over 1 equals 2 pi. C equals pi over 3, and D equals 0. So when figuring out the critical points, since we have a phase shift here, this is what I have to do. My left endpoint, your book calls it left endpoint, that's your first critical point. That's governed by bx minus c equals 0. So I'm going to plug in bx minus c equals 0. So x minus pi over 3 equals 0. So x equals pi over 3. That's our left critical point. Our right critical point, which is the last one, your book calls it the right end. bx minus c equals 2 pi. Plug in. X minus pi over 3 equals 2 pi. So x is going to be 2 pi plus pi over 3. So I get 7 pi over 3. That's going to be my right end. So when I'm doing my critical points, first one is at pi over 3. My last one is at 7 pi over 3. Now remember, I need to divide my period by 4 because that's what I'm going to add each time to define the rest of my critical point. So if I take 2 pi, divide that by 4, I get pi over 2. I'm going to add pi over 2 to each critical point. So pi over 3, add pi over 2 to it, and we will get 5 pi over 6 is our next one. Add pi over 2 to that one, we get 4 pi over 3. Add another pi over 2, we get 11 pi over 6. Add another pi over 2, that takes us to our right end point, 7 pi over 3. So now we're ready to figure out our y coordinates for each of these critical points. And since we're just asked to analyze, we don't have to graph, we're just going to state these points. So we are on a sine function. That means our first critical point is an intersection with the x-axis, so that's 0. I'm going to call that an intercept. And then our next critical point, that's a max. Our amplitude is 1/2, so I'm using 1/2. Next one is another intercept, so 0. Min, negative 1/2. Intercept, 0. Okay, so that's what we should see. All right, we're going to analyze the graph of y equals -3 cosine of 2 pi x plus 4 pi. We have another horizontal translation here. We also have a stretch and a flip. So y equals d plus a cosine of 2 pi x plus 4 pi. D equals 0. I don't have one there. A equals -3, so that tells me my amplitude. Amplitude is always positive, so take the absolute value. So amplitude equals 3, but remember, we have a vertical flip because of the negative there. We also have B equals 2 pi. So from there, period is 2 pi over 2 pi. That equals 1. C equals -4 pi. So we are also going to have a phase shift. So we're going to find our critical points. We're going to start with the left end and the right end. So our left end point is 2 pi x plus 4 pi equals 0. 2 pi x equals -4 pi. So x equals -2. So my first critical point is going to be at -2. So I've got a phase shift to the left of 2. Right end. 2 pi x plus 4 pi equals 2 pi. 2 pi x equals -2 pi, so x equals -1. Now our period is 1, so it does make sense for my critical points to start at -2 and end at -1. All right, so our first critical point is at x equals -2. And we know because this is a cosine, that's going to be a maximum. But we've got a flip. So instead of maximum, I'm going to change that to a -3. My next critical point, remember, take your period and divide it by 4. So 1 over 4. That equals 0.25. So my next critical point is negative 1.75. The next one after that is negative 1.5, then 1.25, and then negative 1 is our last one. The next thing is, so this one, because of our flip, is now a min. We go to the intercept, because we're on a cosine graph. And then because of the flip, we go to a max. Intercept. And then because of the flip, we have a min. All right, so that's what our critical points will look like. All right, now we're going to use a graphing utility to analyze this graph. We've got a vertical translation. We've got D here for the first time. Remember our parent function, y equals D plus A cosine of bx minus c. From here, D equals 2 now. A equals 3. So that gives us an amplitude of 3. B equals 2, so period equals 2 pi over B, so period equals pi. C equals 0, no phase shift. So because we're not bothering with a phase shift, I don't have to figure out where my left point starts. I can just use my, I can use 0. Next thing, remember that we need to divide our period by 4. So pi over 4. So that means that our critical points we are going to start with 0 because I don't have a phase shift. And then add pi over 4. So I get pi over 4, pi over 2, 3 pi over 4, and pi. So there's our critical points. This is cosine. We don't have a flip, so we start at a max. So this is 0, 3. Go to an intercept. Go to your min. Go to your intercept. Go to your max. Now it says use graphing utility. So let's go ahead and graph this and see if we get what we were expecting to get. So I'm going to graph 2 plus 3 cosine of 2x. 2 plus, I need to clear this out. 2 plus 3, 2 plus 3 times cosine of 2x. So there we go. Let's open our table. Okay. So now what we're going to do, you notice how we've started with critical points, but do you see a problem? The problem is we did amplitude, but we didn't take into account our shift up by 2. So therefore, what I need to do is add 2 to each of my y values. Check this out. So it was going to be 0, now it's 2. Max was 3, but I'm shifting up by 2, so I'm going to get a 5. I'm going to go back to 2. My min was negative 3, but shifted up by 2, so I get negative 1. And then I'm going to go back to 2. And now take a look at the graph. See if we can put it where we can see it. Here's the graph. You see how your max is at 5 and your min is at -2? The other thing to notice, we've got a cosine. So it starts at max, goes to min. So there you have it. All right, last thing we're going to do is we are going to find the equation from the graph. So what we've been doing up until this point is starting with the equation and sketching the graph. Now we're going to go the other way. And we need to find the amplitude, the period, the phase shift. Also, we need to see if we're going to shift vertically. And notice how we're centered right on the axis, so we don't have a vertical shift. So amplitude is this distance here. So that's 2. So amplitude equals 2. So from there, A equals 2. Next is period. Well, here we have a crossing and there we have a crossing, so there's intercepts. But that's not the whole period. Okay? Because we have the underside here. So our period is going to start at pi/2 and end at 3 pi/2. So period equals 3 pi/2 minus a negative pi/2. That's going to give us 2 pi. And so we know that 2 pi equals 2 pi over b. So from here, b has to be 1. So I've got A, I've got B. Phase shift. Well, we need to figure out C. Well, our starting point right here is at negative pi/2. That's our first critical point. B equals 1, so I don't have to do the, well, let's go ahead and do it. So the left point is bx minus c equals 0. B is 1, so x minus c would equal 0. Okay, and that c worked out to being negative pi/2. Right? So our left point is whatever c is, and it's negative pi/2. So c is going to be negative pi/2. So then when I write my equation, y equals d plus a cosine of bx minus c, d is 0. So then y equals a is 2 cosine of x minus a negative pi/2. You're going to get a sign change. Why am I saying cosine? Sorry, this isn't cosine. We're always going to use sine. So when you're writing your equations, always use sine. Don't worry about is it sine or cosine. Just use sine each time. So y equals 2 times the sine of x plus pi/2. Okay, thank you for watching and have a great day.